This is Lesson 6, Mystery Computations. Our learning target is I can determine basic relationships between cell values in a spreadsheet by changing the values and noticing what happens in another cell. Spreadsheets are useful mathematical and statistical tools. This image is an example of a spreadsheet. Spreadsheets are made up of boxes. What do we call each box in a spreadsheet? Each box is called a cell. A cell is named using the letters of its column, so these letters go down, and the numbers of its rows. These numbers go across. For example, we can look at cell B2. This means column B and row 2. What is the value of cell B2? Cell B2 contains the value 99. Here's column B and row 2, and that meets at 99. What is the value of cell A4? Cell A4 contains the value -17. Here is column A, here is row 4. We can tell that a cell is selected based on the blue box the computer displays. What cell is selected in this spreadsheet? In this image, cell D1 is selected. Instead of exact values, sometimes we write formulas into cells. This lets us use the values in the spreadsheet to do calculations. In this example, the formula equals B2 minus D5 is typed into cell D1. This means that the value that will appear in cell D1 is the difference between the value in cell B2 and the value in cell D5. Using the values in the spreadsheet, that would be 99 minus 0.25. 99 minus 0.25 equals 98.75, which we can now see is in cell D1. When we press enter after typing a formula, the spreadsheet will do the calculations and show the result in the cell where the formula was typed. Changing the values in the cell used in a formula will automatically update the value in the formula. Suppose the value in cell D5 changed from 0.25 to 20. Since the formula in cell D1 is subtracting B2 and D5, the spreadsheet is now calculating 99 minus 20. We can see that the value in cell D1 changed to 79. Now that we know how formulas change when the cells they use are changed, we can use that to figure out formulas. We can see that column A in spreadsheet A represents the inputs, or numbers that are used in the formula in column B. Right now, we can make some guesses about what the formula in column B is. We need to use some combination of 3, 7, and 10 to equal 7. That could be just 7, or it could be 10 minus 3. We won't know for sure until we try some other inputs. In spreadsheet B, notice that cell A2 changed from 3 to 6. This changed the number in cell B2, so we know the formula in cell B2 does use cell A2. One of our guesses from earlier, that cell B2 is the same as cell A3, is not possible, since A3 did not change, but cell B2 did. Our other guess from earlier, that cell B2 is equal to A4 minus A2, is possible, since 10 minus 3 is 7, and 10 minus 6 is 4. To make sure we have the right formula, we can change another number. In spreadsheet C, cell A2 is still 6, and cell A4 changed from 10 to 15. This changed cell B2, as we expected based on our theory about the formula. Using our formula, it would be 15 minus 6, which is 9, as we can see in cell B2. Since our formula is true for all of our examples, it must be the formula we are looking for. In 3 spreadsheets, we found cell B2 by calculating cell A4 minus A2. So our formula that we would type into cell B2 is equal to A4 minus A2. Sometimes when using a spreadsheet, we need to calculate the sum or product of a list of numbers. Let's first look at how we might be able to write a formula in cell B1 to represent the sum of all numbers in column A. To find the sum of all the numbers in column A, this means we need to calculate 5 plus 3 plus 6. So we could simply type in equals 5 plus 3 plus 6. But we know that it can be helpful to use formulas using cell's column letter and row number so that we can change the values and cell B1 would automatically update. The formula equals A1 plus A2 plus A3 shows that we could write a formula listing each cell with an additional sign in between. But there is an easier way to tell the spreadsheet exactly what we need. The most efficient way to write this formula is by using the sum command, the first cell, a colon, and the last cell. So for this example, we would type the formula equals sum A1 colon A3. All of 3 of these options would give us the value of 14 for cell B1. They all mean the same thing, but the sum command can be most efficient, especially when you have a large list of numbers. Now let's look at how we might be able to write a formula in cell B2 to represent the product of all numbers in column A. To find the product of all numbers in column A, this means we will calculate 5 times 3 times 6. So we could simply type in equals 5 times 3 times 6 into cell B2. But we know that it can be helpful to use formulas using the cell's column letter and row number so that we can change the values in column A and then cell B would automatically update. The formula equals A1 times A2 times A3 shows that we could write a formula listing each cell with a multiplication symbol in between. But there's an easier way to tell the spreadsheet exactly what we need. The most efficient way to write this formula is by using the product command, the first cell, a colon, and the last cell. So for this example, we would write the formula equals product A1 colon A3. All of these options would give us the value of 90 for cell B2. They all mean the same thing, but the product command can be most efficient, especially when you have a large list of numbers.